Welcome to a lesson on diagonal matrices. The goals of this video are to define a diagonal matrix, determine if a diagonal matrix is singular or invertible, determine the inverse of an invertible diagonal matrix, and then finally determine a diagonal matrix raised to a power. A square matrix is called a diagonal matrix if all of the non-diagonal entries are 0 and the main diagonal, or this diagonal here, can be constants or zeros. So a diagonal matrix must fit this form here. If any of the diagonals of a diagonal matrix are 0, or any of these elements here, the matrix is singular, meaning it is not invertible or does not have an inverse matrix. If the diagonals of a diagonal matrix are non-zero, then the inverse of the diagonal can be easily found by using this formula here. To find the inverse of matrix D from the previous screen, we just need to find the reciprocals of the main diagonal as we see here. All their elements will still be 0. So let's look at a couple of examples. We're asked to determine if the diagonal matrix has an inverse, and then if it does, find the inverse. Well, looking at matrix A, notice how the main diagonal does contain an element that's 0, this element here, and therefore matrix A is singular, meaning it does not have an inverse. But notice how the diagonal of matrix B does not contain zeros, and therefore we can easily find the inverse of matrix B by finding the reciprocal of these values here in the main diagonal. So the inverse of matrix B will have a main diagonal where the element in row 1, column 1 will be the reciprocal of 3, which is 1/3. The element in row 2, column 2 will be the reciprocal of -4, which would be -1/4. The reciprocal of 1 is still 1, and the reciprocal of 8 would be 1/8. All their elements will still be 0. Remember, this means that B times B inverse is equal to B inverse times B, which will give us a 4x4 identity matrix. So of course, if we wanted to, we could check this. The last topic for this video will be raising a diagonal matrix to a power. Multiplying diagonal matrices just requires multiplying corresponding diagonal elements. Therefore, if we raise matrix D to the power of m, we just need to raise each element in the main diagonal to the power of m, as we see here. So for example, if we want to find a to the third given matrix A, we just need to raise each element in the diagonal to the power of 3. So a to the third is going to be equal to the matrix where the main diagonal is going to be -2 to the third, 4 to the third, and -3 to the third. Of course, all their elements will remain 0. So -2 raised to the third power would be -8. 4 to the third is 64. And -3 to the third is -27. Okay, that's going to do it for this video. I hope you found this helpful.